Professor. This is Xuan Chen from Group 16. My other group members are Xiaoxiao Li, Wentian Sun, and Ling Zhe. Our project is about U.S. car accident. For the problem statement, because car accidents can cause millions of dollar loss to residents and insurance company every year. So in order to reduce loss, we want to visualize the location where have car accident happen the most frequently as a reference to citizens and urban planning companies to reduce the possibility of the happening of the accident. We also want to offer insurance company uh, a list that can provide the amount of car accidents in states, county, and city so that they can manipulate the setting of coverage in different areas. At the same time, we also want to know what are the factors that influence the severity of the car accident. They might be weather conditions and road conditions. About data description. So our data was downloaded from Kaggle. It's a CSV file. Data size is 1.04 GB, and there are more than 1 million records of car accident with 49 columns of variables in 49 states in America from 2016 to 2019. The variables include the accident ID, the severity, the exact location, including the latitude, the longitude, and the city, county, states of the car accident, and also the time and description of the accident. Weather condition parameter like humidity, precipitation, and road condition parameters like whether there were traffic signal light when the car accident happened. And this is our system design. So firstly, we clean the data. We just delete all the rows with empty values in it, and we delete some columns that are irrelevant to our project, like TMC and some meaningless parameters. And then we're gonna import the data into three different tours. The first one is Hive, and the next one is Tabular, and the last one is SPS, is modular. They all serve for a different kind of functions. The methodology we're gonna use for Hive SQL is we will import the data set into Hive to create a database containing the record of car accident, and we're gonna use SQL editor to and use the code to find out the top location that have most car accident cases. We firstly found the states, the top states, and then the top county, and finally the top cities. And with this information, we can visualize them later using Tabular. We also want to find the distribution of severity. Is served for SPS as modular. And for the methodology we're gonna use for Tabular, we're just gonna use the list come from the Hive SQL, and then we'll know the number of car accident record of any cities, so we know which county, which states have the most accident, and which counties inside that states have the most accident, and we know which city inside of that county has the most accidents. So we can the Tableau can use names of the states, names of the states, name of the county, and name of the city to create a simple map and demonstrate the number of accidents and the location of the states on the map, on the actual map, and we also gonna use the exact longitude and latitude of the car accident in the data set to display the exact location of the car accident in the city, like which row has the most car accident during 4 year, maybe which district has the most car accident. And then for the methodology of SPS modular, um, we're gonna use different kinds of machine learning models to investigate the relationship between the severity and the factors that might influence the severity. Um, we chose to use linear regression model to figure out which weather condition affects the severity the most, and we gonna use decision tree model to figure out which row condition affects the severity the most. This is the result of Hive SQL. Here, the picture shown here is the top 10 states that have the most car accident. And it's also very easy to make the list for county and the list for city. SQL is super easy and convenient to help us extract and list the data we want. It's very convenient. I really like it. And this is a result for tabular. So as you can see, this is the map of Los Angeles in California, the city of Los Angeles in California. So the reason why I chose Los Angeles is because the city of Los Angeles is the top one in the county of Los Angeles, and the county of Los Angeles is the top one in the states of California that has the most car accident record. And as you can see, I use longitude and latitude to plot all the location, and each dot represents the exact location of the car accident. That have more than 10 record, because we think if a location only has one record of car accident, that may be just coincidence. But if a place has more than 10 car accident during 4 years, that place must be having a problem and definitely need remodification. And this is the result of SPSS modeler. The graph on the left is the predicted importance from the linear regression model, and the graph on the right is from the decision tree model. The overall accuracy of linear regression model is only 0.6%. It's showing report, and I will explain why it is so low later. But we successfully found the factor about weather that affects the severity the most is the precipitation at the time when the accident happened, and the factor about the road infrastructure is the traffic signal. So it's very funny that these two variables verify our guesses, because for our real life experience, we know like during rainy days or around traffic light, car accidents are more likely to happen, and further might influence the severity of the accident. So for the conclusion, we successfully extract the data and make them into list using Hive, and we successfully show the states, counties, and cities that have the most car accident, and successfully map all the exact location of the car accident using tabular. Because we cannot just screenshot all the city in the report, so I chose Los Angeles here. And we also successfully get to know the weather condition and road condition that influence the severity the most using SPS as modeler. But we fail to predict the severity because, as you know, we use linear regression model, and the prediction result will be floats like 2.3, 2.7, 3.2, something like that. But the severity are classified to 1, 2, 3, and 4. They're all integer. So only a few of them successfully become an integer to 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 be satisfied for accurately predicted the result. And also, by using Hive, we know that the distribution of the severity is very unbalanced. There are averagely, I think, more than 95% of the severity are level 2 and 3, and very few of them are level 1 and 4 in the city we tried. So I think the SPS model just predict every record to level 2 or 3, and they never can actually predict 1 and 4 accurately. So I think that's the reason why the accuracy is so low. But generally, we successfully accomplished the goal we set at the beginning. The insurance company can use the list to manipulate the price setting for coverage in different areas, and also the urban planning companies can use the visualization result to know where location, which location needs redesign. Thank you.